everyone, welcome back to another video. I hope all of you are doing well. In this video, I'll be talking about how to find the shortest distance between two places and how to find the departure between two places. So if you have watched the previous two videos that I've posted in the general navigation playlist, you would know what is a great circle, what is a rhumb line, how to find the change in longitudes and how to find the change in latitudes. So all this knowledge will come into play in this video. If you have not watched the previous two videos that I posted in the general navigation playlist, I would recommend you to go and watch those first and then continue on watching this video, because if you don't know how to find the change in latitude or the change in longitude, watching this video won't make any sense to you, because all the basics from the previous two videos are being used in this video and you guys will realize that. So once we know what are great circles, what are rhumb lines, how to find the longitudes change and how to find the change in latitude, the next thing that comes in general navigation is to find the shortest distance between two places. And the next thing after that is to find the departure between two places. So all this can be divided into two parts, but I've made that in one big video. So if you want, you can watch it half and half, whatever you guys want. So the first part will be on how to find the shortest distance between two places. Now, if you remember from what is a great circle, you'll know that the shortest distance between two places can only be found on a great circle track. Okay, I've talked about it a lot in this video, but I'm just giving you a quick recap of what you should have known already. So if you know, the great circle distance is the shortest distance. Now, what is departure? So departure means the distance between two places along a particular latitude. So in that, we'll have two longitudes and we'll be finding the distance along a particular latitude. So if your concepts are clear, if you know how to find the change in longitudes and the change in latitudes, then only continue watching this video. Let's start by talking about the first part, which is to find the shortest distance between two places. Now, shortest distance means that we have to find the distance along a great circle. Because if you remember, great circle always gives the shortest distance between two places. Now, even if you look in this diagram, there is a great circle and there are two places P and Q which are plotted on the great circle. Now, if I was to find the shortest distance between these 2 points, I will find the great circle distance, which is shown in the red. Now, how do we find the shortest distance? So to find the shortest distance, first we have to find the angular distance along this particular great circle, and then we convert this angular distance into the linear distance. Now let's say we had to find this distance between P to A on this particular great circle. So what we do is that we find the angular distance. So the angular distance is this, which is 40 degrees. Now, how did we find this angular distance? So this angular distance is nothing but the change in latitudes. So we see that P is on this latitude, which is actually the equator, and A is on this latitude, which is 40 degree north. So this is 0 degree north south, and that is 40 degree north. Now to find the angular distance, we just find the change in latitude. So change in latitude, we have seen how to find it in the previous video. So the change in latitude obviously comes to 40 degrees north. And now we just convert this 40 degrees north into the linear distance. Now, how to convert the angular distance into linear distance? We use these two conversion factors, which are very, very basic. So it says 1 degree equals 60 nautical miles. Thus, 1 minute will be equal to 1 nautical miles. Now, a point to keep in mind is that this degree or minute is depicting angular distance, or we can call it the change in latitude or the change in longitude. Okay, because obviously change in latitude and change in longitude is nothing but the angular distance. Yep, so that is how we will convert angular distance to linear distance to find the shortest distance between two places. Now, if I talk about the type of questions you'll get in the exams, so there are these 6 examples which you'll find in the Oxford's General Navigation book, page number 31. In this video, I'll solve all of these 6 examples. So let's look at them one by one. So in the first one, it wants us to find the shortest distance between these two coordinates, A and B. Now, just by looking at this question, I can see that both of these coordinates are lying on the same longitude, which is 0 degrees 12 minutes west, and it is the same over here also. So both of these are lying on this longitude. So now let's just go ahead and plot these 2 points. So let's plot the 0 degrees 12 minutes meridian. So this will be the North Pole, which is 90 degrees north. This will be the South Pole, which is 90 degrees south. This is the equator, which is 0 degrees north south, and this is our longitude, 0, 0, 0 degrees 12 minutes west. Perfect. And this, of course, is the center of the earth. So the point A is at 51 degrees 37 minutes north latitude. So let's say this is A, and this makes an angle of 51 degrees 37 minutes north. The next point B is at 6 degrees 48 minutes north. So let's say this is point B, and this point is making 6 degrees 48 minutes. So I'll just write the latitudes here as well. Perfect. Now the distance between these 2 points will be this. Now to find this, I want to find the change in latitude. So the change in latitude between these 2 points will be now we have this change in latitude. To convert this to distance, I'll just use these. So over here it is 44 degrees 49 minutes. So I saw 1 degree equals 60 nautical miles. So 44 degrees will be equal to 44 into 60, which is equal to 2640 nautical miles. And we had 49 minutes. So we'll just add 49 to this, and the distance will be 2689 nautical miles. So this is the distance between point A and point B. So you see how easy it is to find the shortest distance? Now we'll just look at the next example. So in the next example, it says that we have to find the shortest distance between point D and point E. Okay. So here also, if you look at the question very closely, you'll find that both of these are again on the same longitude of 030 degrees 30 minutes east. Okay, let's go ahead and plot this. So this is 030 degrees 30 minutes east. So this will be my meridian of 030 degrees 30 minutes east. The first point lies at 29 degrees 30 minutes south. So let's say this is the point D. And the next point, which is point E, is at 59 degrees 47 minutes north. So let's say this is E. This is the center of the earth, and if you want, I'll just join both of these points as well. Now we have to find the shortest distance between these 2 points, which we know will be this, since it is along the great circle, that is the blue one. Now to find this, we'll have to find this angle first, and to find this angle, we'll have to find the change of latitude. So the change of latitude over here will be perfect. Now we have this angle, which is 89 degrees 17 minutes. And now to get the red distance, I will just have to convert this angular distance to linear distance. And how do we do that? So I'll just use the conversion factor and it will come out to be 89 into 60 plus 17 nautical miles. This comes out to be 5357 nautical miles. Perfect. So the distance between point D and point E is 5357, and this is the shortest distance between these 2 points, since we have found this distance on the blue great circle. Perfect. This was also a very easy and straightforward question. Let's move ahead. Now in example number 3, we again have to find the shortest distance between point F and point G. Looking closely, we can see that these are not lying on the same longitude. Okay, do you know the reason why I'm only looking at the longitude and not the latitude? The reason is because I am only concerned about the great circle distance. And great circle distance means the distance along a great circle. And latitudes are not great circles. My longitudes are great circles. That's why I'm just looking at the longitudes, because to plot these points, I will only have to use the longitudes. Okay, perfect. So now a trick. So whenever you find the longitudes are different, just add both of the longitudes up and see what happens, which can also be written as 180 degrees. So do you know what this 180 means? This means that both of these longitudes are exactly opposite each other. So if one longitude is this, the other one will be this, which is actually the anti-meridian of the first one. So whenever longitudes are different, just add these up and see if the sum is coming to be 180. If the sum is 180, then you know that one is the meridian and the other one is the anti-meridian of that. So we have a basic idea of how to plot these points now, right? Let's go ahead. So my first longitude is the east one. So let's plot it here. This is 011 degrees 10 east longitude, and the other longitude is 168 degrees 50 west. Okay, so that is how we plot these meridians now. So now the first point, which is point F, this lies on the 01110 east longitude, and the latitude is 41 degrees 55 minutes north. So it is probably here, point F. And point G lies on the green longitude with the latitude at 21 degrees 17 minutes north. So it will probably be somewhere here. Perfect. Let's join these two to the center of the earth. And we are supposed to find the shortest distance, which will be this distance along the great circle. And to find this distance, we will have to again find this angle. To find this angle, we will find the change in latitude. Okay, so now we have the angular distance. To convert it to linear distance, it will be 116 into 60 plus 48 nautical miles. So this is this red distance from point F to point G. Now let's look at the fourth example. So in the fourth example, again the shortest distance between point J and point K. The longitudes are again different. So let's try and add both of these up. And this again comes out to be 180 degrees. So again we know that both of these longitudes are behind each other. So one will be the meridian, the other one will be the anti-meridian. So if this was the 13535 east longitude, this will be the 04425 west longitude. Let's plot the 2 points. So the first point, which is point J, lies on the east meridian at 35 degrees 57 minutes north. And the other point, which is point K, lies on the west meridian at 22 degrees 10 minutes south. Now the shortest distance between both of these will be along the North Pole. Now here also we'll just find the change in latitude, and to find the change in latitude here we'll have to subtract this angle from 180 degrees and then add this angle. So I've done all of these questions in the previous video. If you haven't watched the video, please do that. Which is this angle between both of these places. Now to convert this to linear distance, so the shortest distance between point J and point K is 9973 nautical miles. And it is along this great circle, which is half blue, half green. Perfect. So you see, all of these questions are very easy if you know how to find the change in latitudes correctly. So the fifth example now. So in this, again, the shortest distance between this and this. Here, if you look at this question closely, you'll find that the latitude of both of these points is 0 degrees north. Now, what do you mean by 0 degree north? 0 degree north means the equator. So this question says that both of these points are at the equator and their longitudes are different. So what we'll do here is that we'll plot the equator first. You know, we always plot the stuff that is common with both the points. So either the points are on the same longitude, we plot the same longitude. If the points are on the opposite longitudes, so we plot the meridian and its anti-meridian. Now here, since the points were on the equator, we'll plot the equator. And if you guys noticed, whenever I was plotting the meridians or the anti-meridians, I was always using the equator to cut it into two halves. Because obviously the equator is the latitude which cuts the earth in two halves. But here, since I'm plotting the equator only, which is the latitude itself, I will use the prime meridian to cut it in two halves. Okay, so this will be 180 degrees east/west and this will be 0 degrees east/west. Yeah, so this will be the eastern part and this will be the western part. Obviously. So now let's plot the places. So place D is on the equator at 016 degrees 35 minutes west. So it will probably be somewhere here. And point M is on the equator at 103 degrees 55 minutes east. So it will be somewhere here. If I join these places to the center of the earth, we'll have this angle. And this angle will not be the change in latitude, but the change in longitude, because the latitude is the same for both of them, which is 0 degrees north or south. So to find the change in longitude, we just add this angle to this angle. Now to find the shortest distance, which will be this along the equator, and equator is also a great circle, so obviously it will be the shortest distance. We'll just have to convert 120 degrees to nautical miles, which will be this plus the remaining minutes into nautical miles. So this comes out to be 7230 nautical miles. So place L and place M are 7230 nautical miles apart along the equator, which is a great circle. So this is the shortest distance between these two places. Okay, now let's look at the last example, which is also a special case. So in this question, it says that both of these places are geometrically opposite to each other. Now, geometrically opposite means that these two places are exactly opposite on the Earth. Like if I talk about the North Pole and the South Pole. Both of these places are geometrically opposite. If I talk about this place and this place, or this place and this place, you see both of these are exactly opposite each other. So these places are known as geometrically opposite places. And now to find the shortest distance between these 2 points, let's plot them first. So let's make the longitudes first because it is a great circle distance. So here the longitudes are 0 degrees east and 180 degrees east. So let's say this is my 0 degree east longitude and this is the 180 degree east longitude. Perfect. So if I look at the first place, it is at 51 degrees 30 minutes north and on the 0 degree east longitude. So it will be on the blue line at 51 degree north. The next point P is at 51 degrees 30 south but on the green line, which is 180 degree east longitude. Now if I join both of them to the center of the earth, it will be more or less a straight line. And you can see in this also that both of these places are exactly opposite each other. So to find the angular distance between both of these places, it is clearly 180 degrees. And the linear distance will be exactly 180 into 60 nautical miles, which is 10800 nautical miles. So this is the shortest distance between both of these places. Now which side will be the shortest distance? So since both of these places are exactly opposite, it can be either this distance or this distance. Both of these will be 10800 nautical miles. Okay, now the question is that how will you know if the points are geometrically opposite to each other? So if you look at both of these coordinates closely, let me just write both of these here. Now, to find if these are meridians and anti-meridians of each other, we'll add the longitudes up. Okay, so this 180 shows me that both of these places are on the meridian and the anti-meridian of each other. Now looking at the latitudes, I see that both of these latitudes are exactly the same. It's just that this one is in the northern hemisphere and this one is in the southern hemisphere. So whenever you find something looking like this, where the longitudes are adding up to give 180 and the latitudes are exactly opposite to each other, so one is in the northern hemisphere and the other is in the southern hemisphere, then you know that these two places are geometrically opposite. Okay, perfect. So this was how we find the shortest distance between two places. Now all of these are very easy if you know how to find the change in longitude or the change in latitude, and these are the only 5-6 type of questions you can expect in the exams. So if you understand these 6 examples, the exam question will be very easy for you. Now let's go on to the second type of distance we can find between two places. This distance is known as departure. So departure is the distance between two longitudes along a specific latitude, and it is always given in nautical miles. So let's take these two longitudes. Looking at these, we can see that the distance between the two longitudes is not same at all latitudes. Like here it is the maximum, here the distance is less, and it is 0 at the poles. So because the longitudes are converging at the poles, the distance at every latitude is different, and this distance along a latitude is known as departure. Okay, so the departure is maximum at the equator and minimum or 0 at the poles. So just by looking at this trend, we can say that the departure follows a cosine function, which means that the departure is maximum at the equator, which is 0 degrees north-south latitude, and as the latitudes increase, the departure decreases and it becomes 0 at the poles, which is 90 degree north-south latitudes. And also, since the departure is measured along latitudes, it is known as a rhumbline track. When the distance between 2 points was calculated along the great circle, we called it as a great circle track or a great circle distance. But here this is a rhumbline track or a rhumbline distance, because we know that all latitudes are rhumblines. So now for rhumbline track, there is a formula which is used to find the departure at different latitudes. And this formula says that departure is equal to change in longitude into cos of the latitude we are finding it at. And one thing to keep in mind is that this change in longitude should only be in minutes. So if you get an answer in degrees and minutes, just convert everything to minutes before using this formula. Okay, so this is a very easy and basic formula. Let's say we have to find the departure between two longitudes at the equator, and the change in longitude is given to be 30 degrees. So let's say these are the two longitudes, and the Shillong is given to be 30 degrees. We are supposed to find the departure at the equator. So we'll just use the formula. It will say that departure equals change in longitude 30 degrees, but I have to convert it to minutes. So it will be 30 degrees into 60 minutes. Now the answer will be 1800 minutes. So my departure is 1800 into cos of latitude. So the latitude at the equator is 0. So it will be 1800 into 1, which is equal to 1800 nautical miles. So now this is the distance over here, which is 1800 nautical miles. Similarly, now if we wanted to calculate the departure along the same longitudes at the pole, so how will we do that? Shillong is 30 degrees only, so I'll put the formula, which is departure equals Shillong into cos of 90 degrees. 90 degrees, why? Because the latitude at the pole is 90 degrees. So my answer will come out to be 1800 into 0, which is 0 nautical miles. So we can see that the departure is 0 at the poles and it is maximum at the equator. I hope you understood the idea behind finding the departure. So now let's look at some of the type of questions you can get in the CPL or ATPL exams. So I have these three type of questions and I'll solve these one by one. So the first type of question is the easiest and the most basic one. In these questions, they will give you two longitudes and ask you to find the distance between them at a particular latitude. So this can be solved by finding the change in longitudes and substituting everything in this formula. But just keep in mind that this change in longitude has to be converted purely to minutes. So now if we look at this example, it says that a flight is to be made along the parallel of latitude from A to B. Calculate the distance. Okay, so here we have 48 degrees 0 minutes north latitude, and the longitudes are 04 degrees west and 02 degrees 27 east. So let's plot these points now. So this is my equator, this is the prime meridian, this is my 48 degree north latitude. Now the two longitudes which I'm given are 4 degree west, which will be here, and 2 degree 27 east. So what I am supposed to find is this distance, which will be the departure. So this is along 48 degree north latitude between 4 degree west and 2 degrees 27 minutes east. So how do I find this? The first thing I'll have to do here is find the change in longitude. Now if you don't know how to find the change in longitude in this case, just watch the previous videos and I'm sure you'll get an idea of how to do it. So here the change in longitude comes out to be 6 degrees 27 minutes. Now I'll convert this to minutes. So it will be 06 degrees into 60 plus 27. So this is my change in longitude. Now I'll just substitute everything in the formula. So it will say departure will be equal to 387 into cos 48. And that is the departure. So 258.9 nautical miles is this. Okay, very easy. So yeah, again, as long as you know how to calculate the change in longitude, these questions will be easy for you. Yeah, let's go on to the next type of questions. Okay, so the next type of questions may look something like this. So in this, you are given one coordinate and the departure, and you're supposed to find the longitude of the other point. So let's read this question first. It says an aircraft flies for 1000 nautical miles along a rhumb-line track of 090 degrees true from C, which is here, to D, and it wants us to find the longitude of D. Okay, so let's start by plotting the point C. So it is at 36 degree north latitude on a longitude of 174 degrees 45 east. So my point C will be this. Now, according to the question, it says that my aircraft flies 1000 nautical miles along a rhumb-line track of 090 degrees true. So, as we know, this is 000, which is also known as north. This direction is 090, which is east, south 180 degrees, and west 270 degrees. In the question, it says that my aircraft has flown a track of 090. So my aircraft took off from C, travelled 1000 nautical miles along this track of 090 degrees, and it reached a point D. So this is point D, and what we are supposed to find is this longitude, which is passing through D. Okay, so I hope you understood this question. Okay, so let's plot all this in this way as well. So that is my latitude, which is 36 degrees north. This side is east, this side is west, that is 0 degree east-west, and this is 180 degree east-west. So that will be the prime meridian and its anti-meridian. So now the first point I have is point C, which lies on 174 degrees 45 minutes east longitude. So it will somewhere be over here, let's say it's here. And it says that my point D is on a track of 090 from C. So 090 is east, and by looking at this diagram I can say that east is this way, right? So my point D will somewhere be over here. Yeah, it should be east of point C. Okay, so now let's solve this question to find where exactly is point D. So if I use the departure formula, it says that departure is equal to Shillong into cos of latitude. So here I have the departure, which is 1000 nautical miles, equals Shillong. I don't have the change in longitude, but I have the latitude, and the latitude is 36 degrees. So using this I can find my Shillong, and this comes out to be 1236 minutes. And if we convert this to degrees, it will come out to be 20 degrees 36 minutes. So this is not my answer. This is just the change in longitude. So I knew this was 174 degrees 45 minutes east. Now I know the change in longitude between C and D. So I don't know the longitude, but I know that the angular distance is 20 degrees 36 minutes. Now what do I do with this? So I come back to this diagram now. Here I see that D is supposed to be on this side along this red arrow, and I also know that the change in longitude between C and D is 20 degrees 36 minutes. So if I go 20 degrees 36 minutes this side, I get the point D, which is on longitude of 164 degrees 39 minutes west. So this is my answer, 164 degrees 39 minutes west. This is the longitude of point D. Now you would say that when you added 20 degrees 36 minutes to 174 degrees 45 minutes over here, the answer was somewhere close to 194, 195 degrees. But how did I write 164 degrees? But then I have to take care of a fact which says that my longitudes cannot exceed 180 degrees. And if it's exceeding 180 degrees, that means you're going over the western side. And then again you'll have to subtract it from 180 to get the answer. Let me know if you guys didn't understand how did I get 164 degrees 39 minutes, but I think it's self-explanatory and it's very basic. So this was the second type of question where we used the departure and the latitude. We found the Shillong first. So this was our Shillong. And then after looking at a diagram like this, we saw that we had to go towards the east. That means we'll add. And as we were going over the 180 degree east-west anti-meridian, we subtracted it to get this answer of 164 degrees 39 west. Okay, amazing. Now let's go on to the third type of questions which can be asked, and it may look something like this. So in this question, if you read, it has given you 3 rumb line tracks and distances, and these are starting from point E, which is at 50 degree north latitude. So it says E is at 50 degree north latitude. The track from E to F is 000 degrees true and is 300 nautical miles long. From F to G, it is 090 degree true and again 300 miles long. And the track from G to H is 180 degree true, which is also 300 nautical miles long. And what we are supposed to find is the rumb line bearing and distance of H from E. Okay, we have to find E to H. Now how do we solve this? So now let's start by plotting all of these rumb line tracks. So let's say this is my 50 degree north latitude and this is my point E over here. Okay, so it says E to F, there's a track of 000 degrees true. So the track will be over here and this point is point F. This is 300 nautical miles long. Next it says that F to G is 090 degree true and 300 nautical miles. So this is my point G, which is again 300 nautical miles. And from G to H it is 180 degree true and 300 nautical miles. And I'm supposed to find the distance and the rumb line track of H from E. So E to H is unknown. So now looking at this diagram, I can say that I have 2 latitudes. One is 50 degree north, the other one is unknown. And I have 2 longitudes. Now this looks like a square, but it is actually something like this. So these are the 2 latitudes, this one's 50 degree north. And the 2 longitudes are actually something like this. Because obviously these converge at the North Pole, right? So if you remember what we talked about in the beginning of this video, the departure is different at all latitudes. And that's why we can say that this distance is not 300 nautical miles. Because obviously it looks like a square which should give equal distance. But since the departure is different at different latitudes, this won't be 300 nautical miles. Perfect. Now to solve this question, there are 2 ways. One is a very long method where you'll have to apply this departure formula everywhere. So one way is to apply this formula on every leg and find the coordinates. The other method is to use this formula. So if we use this formula, this question will be very easily solved and it won't take a lot of time as well. So now if we solve it by the first method, we can say that this distance is along a great circle because it is a longitude, right? So we can write it as 300 equals change in latitude into 60. Yeah, which is the shortest distance. So now we can find the change in latitude. So the change in latitude will come out to be 5 degrees. Okay, so you understand how I got this? I used the shortest distance formula. I had the distance given to me as 300 nautical miles, and I just used the formula which says 300 equals change in latitude into 60. I just substituted the values and the change in latitude came out to be 5 degrees. Now, this latitude was 50 degrees, and since the change in latitude is 5 degrees, this latitude will be 55 degrees. Yeah, that is 55 degree north, because the change in latitude or the difference between the two latitudes came out to be 5 degrees. So the other latitude will be 55 degrees north. Now the next thing that we know is that this rumb line distance or departure is 300 nautical miles. So I'll use the formula which says 300 nautical miles equals change in longitude into cos 55 degrees. Yeah, because I have the latitude now. So if I find the change in longitude, it will come out to be 523 minutes. Okay, so the angular distance between both of these longitudes at this latitude of 55 degree north is 523 minutes. Okay, now if you think about it, the change in longitude will always stay the same, right? Irrespective of the latitudes we're talking about, because it's the angular distance. So I can say that the change in longitude at the latitude of 50 degree north will also be 523 minutes, correct? So I'll write 523 minutes. Now if I put it in the formula to get the departure, it will be change in longitude, which is 523 minutes into cos of 50. So my departure will come out to be 336 nautical miles. Now this is the distance between place E and place H. Now to find the rumb line bearing of H from E, it will be 090 because H is east of E. Okay, understood. Now if I wanted to solve this question by using this formula, what I'll do is just substitute the values. So I can say that the departure at latitude 55 degree north is 300 nautical miles. So I'll just write 300 nautical miles upon departure at 50 degree north, which we don't know, equals cos 55 upon cos 50. Now if you solve this, the answer will again come out to be 336 nautical miles. Okay, perfect. So in this question, you can do it both ways. Either you can just apply the formula. To use this formula, you'll have to find the departure at least one latitude and then use the change in latitude to find the new latitude. And if you have the new latitude, you can easily find the departure. Okay, so this was a bit tricky question. If you didn't understand this question, just let me know. I'll make another video on just solving this particular question. Perfect. So these were literally all the type of questions you can get in the exam from these two topics. I know these are very easy, but if you know how to find the change in longitudes or the change in latitudes correctly, if you don't know how to find the latitudes or the longitudes change, you won't be able to solve any of these questions. Now, in the exam, they can confuse you by changing these values from nautical miles to statute miles or to kilometers. But if you know the formulas well of how to find the departure or to find the shortest distance, you can just use these conversion factors to convert between nautical miles to statute miles to kilometers, anything. So just remember the conversion factors and the formulas. So now this was all from my side. I hope this video helps you in some way or the other. And if you have any doubts, any queries, again, just feel free to comment or DM me on Instagram. And I'll see you next time. Thanks for watching.